And do you remember which number it was?
Number 3.
3, huh? Okay.
Yeah.
So this one, I suppose.
Mm-hmm.
Use the given information to find the number of degrees of freedom. The critical values XL and XR and the confidence interval estimate of sigma. It is reasonable to assume that a simple random sample has been selected from the population film distribution. Nicotine in menthol cigarettes, 90% confidence, sample size, standard deviation. Okay. Okay. So were you able to try anything?
I tried it, but I did not get it. I think the only thing I got was the DF.
Ah.
Yeah.
What did you try? Did you try anything else besides the DF?
I was not sure what to do.
Okay. I see. All right. So if do you have the green cardstock with you?
Yeah, let me get it on the back. Yeah, I got it.
Okay. So what I put on the screen is the same green cardstock,
Yeah.
and this is my version of it. And on the inside,
Mm-hmm.
in the upper left-hand side where it talks about confidence intervals,
Yeah.
there is the first bullet point is for the population mean. The second bullet point is for the population proportion. The third bullet point, that's the one you want, is for population variance. You see that?
Yeah.
Okay. Now that is the confidence interval.
Yeah.
And in order to use this formula,
Mm-hmm.
you need to know what n is. And if you found the degrees of freedom, you must have known what n was.
Yeah.
You also need to know what the sample standard deviation is,
Yeah.
and that's given in the question.
Mm-hmm.
The only thing that's not given, the part that you have to figure out, is what is chi-square r and chi-square l.
Yeah.
Once you have all those numbers, you can do the math, and then you'll have a confidence interval. Okay?
Yeah.
So if you saw this in a test, this is where you would look, and you would just be looking, trying to figure out what numbers go where. Okay?
Yeah. Mm-hmm.
So let's see here. What am I looking for? So coming back to the question, in this particular case, it says that nicotine in menthol cigarettes is 90% confidence. 90% confidence. So what I would recommend, if you're doing this
Yeah.
yourself, is you write down what you see in your notes.
Okay.
Can you see that? Is that too small?
Yeah. It seemed to be too far.
Okay, I'll try and write bigger.
Okay.
I'll use a darker color too. This is the same formula that you see on your green cardstock.
Mm-hmm.
Okay?
Yeah.
So I just copied down what you see over there. And so you come back to the question that you're trying to answer. And I suppose maybe your numbers are your numbers different from the ones that I see?
Yeah, they must be different, but as long as we do this one, I'll be able to do the one that I have.
Good. Okay.
Yeah.
So in this particular case, you can see that we're dealing with a 90% confidence. Your goal is to find a 90% confidence interval where n That is to say the sample size is
22.
And S, that is to say the sample standard deviation,
Yeah. 0,
0.23.
2, 3.
So now you can see what N is.
Yeah.
N is
22.
22. This N is also.
22.
And S.
0.23.
Yep. And we're going to be squaring that eventually. So you'll need a calculator eventually. But before you reach for your calculator, we still need to figure out what number goes here and what number goes there.
Yeah.
Okay. Well, anyway, let me go ahead. Actually, you can already see what the degrees of freedom are, though. So you know the degrees of freedom is 22 minus 1?
Yeah.
At least in my
21.
So I'm going to put in 21.
Mm-hmm.
So far, so good. Chi square L. Okay, so I recommend that you draw a picture.
Okay.
And I guess I'll draw I think I have enough space to draw the picture right here. So my picture is going to start at 0. It climbs up quickly and then decreases slowly. So it starts at 0, but it keeps decreasing forever.
Okay.
And that's your chi-square distribution. Notice it's the same picture that you see on your green cardstock notes on the very back. Remember that part?
Yeah.
It's the same picture that you see there.
Yeah.
And over here where it says, so L is short for left, R is short for right. I can draw a line right here and a line over here. This is chi square L. This is chi square R. Let me adjust that a little bit so you can see it a little better. Can you see that?
Yeah.
Okay. And the only thing what you have to do is to figure out is this over here is a left tail.
Yeah.
This over here is the right tail.
Yeah.
And the area to the left of chi square L is the area of this space. And the area to the right of chi square R is shown over here.
Mm-hmm.
The tricky part is, what is the area of the left tail? And what is the area of the right tail? Do you know?
I think it's 0.5.
Close, 0.05.
Yeah, because the middle is 90, so the middle is 0.9.
That's right.
Yeah.
So the remaining 10% is
You divide by 2.
tails. So that's going to be 0.05 and 0.05, so that the middle has 90% of the area. Very good. So now you're ready to come back to your table, and there's lots of numbers to pick from. And so, but to know which number to pick, you have to look at the columns and figure out which is the correct column. And you have to look at each of the rows and figure out which is the correct row.
Okay.
So any ideas?
Yeah, I think the DF that we are looking is, the number that we are looking is 0.95 and the DF is 21.
That's right. That's right. So yeah, so right here, the area to the right of it is 0.95 because it's 90%, including the 5% over here.
Yeah.
And the degrees of freedom is 21, like you said. So I'm looking at the 0.95 column and looking for the row that corresponds to 21 degrees of freedom. I think that's it right here, right?
Yeah, it's 11.591.
Okay. There it is. But we still need one more number. I need chi-square r.
Yeah,
And where will I look in the table for chi-square r?
0.05.
Right. So that's this column right here.
Yeah,
And going down to the 21st row, I think it's this one, right?
is 32. Yeah, 32.671.
That's it. And so now I'm ready to come back to here and here.
Yeah.
And I'm going to replace chi-square r with 32.671. And I'm going to replace chi-square L with 11.591.
Okay.
So I'll go ahead and put that down. That's 32.671 and 11.591. And that's the hardest, I think the hardest part is just coming up with each of those numbers.
Yeah, that is the hardest part. Otherwise, it's okay.
Yeah. In fact, I think I can go ahead and enter some of these. So
Yeah.
chi-square L we said is 11.591, 0.591, and chi-square R
32.671.
32.671.
One.
Yeah. Nice. So now the confidence interval, this is where I need the calculator now.
Yeah.
So what I'm going to do, since I've already plugged in all the numbers here, 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 and here, I'm going to go ahead and erase this. And I'll begin by calculating this number over here on the left.
Okay.
And we'll go ahead and, let me see, I think I have a calculator like yours. It's just loading.
Okay.
But yeah, you can try this on your calculator with your numbers.
Yeah, I'm trying.
Okay. Okay. So I'm looking up here for mine. I have, I know I can do 22 minus 1 in my head.
Yeah.
So I'm just going to type in 21 times
0.23 squared.
Squared, right? And then I'm going to divide that by
32.671.
exactly. And what I end up with 0.034 with a bunch of zeros after it.
Yeah, 20.
Now notice, technically this is a confidence interval for the variance, not the standard deviation.
Okay.
But we'll handle that in the next step.
Okay.
The next line is going to be, now the right hand side is basically the same thing. I have a shortcut. I just do second entry right here. Brings up everything there. It's pretty much, the numerator is the same. The only thing that's different is the denominator. I'm going to type in 11.591 instead.
Okay.
So 0.095 8, 4, lots of other digits. And so I really should have written down more digits, but that's okay because all the digits are in my calculator, and I'll show you how I do that so that I don't lose any accuracy.
Okay.
But right here in the middle, if you compare this to the, see how the question has a sigma standard deviation, but there's not a square on it.
So you have to look for like the square root?
Exactly. So the next thing I'm going to do is I'm going to take the square root of this, the square root of this, and the square root of that.
Yeah.
The square root will undo the square, leaving me with just sigma, which is what I want. But on my calculator, I think the easiest way to do that is press the up button a couple times.
Yeah.
Actually, wait. I want to take the first type in square root.
Yeah.
Then press the up arrow. And that way, when I press that number, it puts it inside the square root. So it's actually keeping all the digits. And I can actually write them down. So I think that's a good idea.
Yeah.
And for me, I end up with 0.18. I'm going to say 184. I decided to round off to 3 digits because my original sample standard deviation had 2 digits.
Yeah.
So usually we just keep 1 extra.
Okay.
So 184. And we'll do the same thing over here. Now in this case, because of it, I see 309, but after the 9 comes a 5.
Yeah.
So I'm going to round that 9 up to a 10.
0.31.
Yep. And so in summary, my sample standard deviation was 0.23.
Mm-hmm.
So I would expect the population standard deviation to be somewhere between 0.184 and 0.310, at least with 90% confidence. Those are the numbers I'm putting in right here. The confidence interval estimate of sigma is, and actually the instructions do say to round to 2 decimal places.
Mm-hmm.
So I guess I can round it up.
0.18.
Mm-hmm.
.31.
Yep. And that should be okay.
Yeah.
Nice. And that's how it goes.
Yeah, that will be able to do that.
Mm-hmm.
Yeah.
Yep. Is that enough for that one?
Yeah.
Okay. Cool. Yeah. Yeah. So I think if you, looks like the other ones are pretty similar.
Yeah. So if I am able to do that one, I'll be able to do the rest.
Good. Okay.
Mm-hmm. Yeah.